We talked about this, I think, in March or February originally. So I appreciate us following through with you, and I thank you for coming out tonight and putting your team together. So Art joined at the Advanced Design Department in 1963. So appreciate all your hard work on that. I've been in the Advanced Design Department. It's now, so I can't imagine what it was like back then. Working on many of the advanced experimental aircraft here at Sikorsky, including the advancing blade concept, which obviously is the precursor to everything we stand behind now. And also working on the original rigid coaxial speed of 259 back then, right? So in 1987, which is actually the year I was born, you were named engineering manager for the LHX program, later called Comanche, which you went on being program manager and then Boeing Comanche program director. Retired in 2000. So appreciate you coming out tonight. Appreciate the resume. Hopefully that means you're looking for a job. We'll talk to you afterwards. And with that, Art, thank you so much. Oh, you want to go on that? Yeah. Otherwise, I can. Okay. Thank everybody for coming out. I think we're going to do a little walk down memory lane here. He's not the only one who wasn't born when we were starting off this one. I'm really going to start way back and give you like a 2-minute history of Sikorsky aircraft. Because it's the way we all started.
Excuse me, Art.
Yes.
Is that mic working?
Is that not loud enough?
Closer to your mouth.
Our things are getting better. Can you hear me? No. If you can't hear me, raise your hand. 2 buttons. I don't know. Okay, so like I say, I want to start really in the very early days of Sikorsky and show you how all this evolved. So we will start with this one. Am I hitting the right button?
Alex, you need to index the slides.
Oh, let me click on it. Now try it. There we go. Now, this is Sikorsky aircraft pre-Black Hawk days. This thing is from 1940 to 1980, and this is the production of the company during those years. And Sikorsky, of course, started in the Second World War with a small amount of production, and some lean years after the Second World War. But then during the 1950s, Sikorsky built the big piston-powered utility aircraft, the S-55 and the S-58, and the company was booming. They at that time built the new plant along the Housatonic River that has been there forever. But that was kind of new when I first came to the company. But the issue was that then we got into the 1960s, and the industry converted really from piston engines to turbine engines. We had the S-61s, the SH-3s, and they were moderately successful. We got into the 53A. We built a sky crane, but what we were building were not high-volume aircraft. And there really was an issue about what do we do next. And as we said in the introduction, I was working in advanced design. And there was a fellow in our department who had a chart in his lower left-hand drawer where every year he put another point on that chart. And it was the information from Aviation Week about which companies produced how many helicopters. And the Sikorsky curve was doing just that. And he referred to that as the going out of business curve, which it really was. And we were in advanced design trying to figure out what are we going to do to come up with some products which will keep this company going. And of course, the next thing that came was the UTAS, which became the Black Hawk. And that was a huge program, a program that we as a company knew we had to win. And it was for a utility aircraft, which really was the bailiwick of Bell helicopters. Bell was building the Hueys, Bell was building the Cobras. This proposal went out, and everybody assumed Bell was the obvious winner. But we didn't have a lot of choice. We had to compete because that was kind of like the only logical line of future business. And lo and behold, we competed and we won. And we won that along with Boeing to build 2 aircraft for a competitive fly-off. And that, of course, is our UTAS. Everybody knows and loves about Black. We won the competitive development contract in 1972. We built the prototype aircraft. We then did a fly-off with a Boeing design. We beat Boeing in the fly-off. And in 1976, we won the contract. That truly is what saved the company. There would be no company right now if we didn't win the Black Hawk contract. At that time, they were going to build 1,107 aircraft. Of course, we all assumed that it would go on beyond that. So I bring this up because after we got the UTAS going, and Hughes in those days got the Apache going, we then got into, well, what's the next step? Well, the next step was what they originally called the LHX. And this was an aircraft to replace the whole light fleet that they had from the Vietnam War, the OH-6s, the OH-58s, the Cobras, the Hueys. And the Army had a wildly ambitious plan. And when you look at some of this, they want to replace all of their aircraft. They had 7,000 current aircraft. They were going to identify how they came up with this number, I'm not quite sure, but they said we need 4,929 aircraft. A huge contract. So large that, in fact, they recognized that probably no one company could handle that. And in addition to that, it probably was going to drive somebody else out of business if all of this large contract went to one company. So they told the 4 helicopter companies, you have to combine into two company teams on your own. You can figure out how to break that up. Well, Sikorsky and Boeing teamed up. We call ourselves the first team. And that left McDonnell, Douglas, and Bell to compete against us, and they call themselves the super team. Now, because there was still a very large contract, they were, ahead of myself, one other thing, let me say. The plan at that time was that both teams would build aircraft, and like the UTAS Black Hawk, there would be a competitive fly-off. And from the competitive fly-off, then you'd go into production. And again, because of the huge number of aircraft that they were dealing with, they said that once one of these 2 company teams won the program, both aircraft, both companies would be tooled up for production. And once we got into production, each lot would compete, Boeing versus Sikorsky. So again, they would be sharing the work as we all went forward. So here we get to the Comanche. This is our shot that shows we actually in the end built 2 of them, 2 prototypes. The thing that was fun from an engineering standpoint about the Comanche program was the technology that had evolved from the UTAS Apache days. We were really at the cusp, at the beginning of the whole digital age. We were no longer designing aircraft with people leaning over drawing boards. Now we were designing the aircraft on the computer. We had electronic capability for some of our sighting systems and our weapon systems that had never been heard of before. And it was literally growing by leaps and bounds. We had the opportunity, because it was what in those days referred to as a clean sheet of paper approach, although we didn't use paper anymore, to incorporate a lot of new technologies that had been evolving over those 20 years since we designed the UTAS. And those get into things like, we thought we could build a bearingless rotor. Let's eliminate all of the hinges in the rotor. We were going to build a new concept for the main gearbox, where we were going to eliminate the planetary gears in the gearbox. We were going to build a fuselage out of composite material rather than sheet metal. The Army had asked us to eliminate the tail rotor because they thought that was kind of dangerous in flight. So we had this opportunity to develop this new anti-torque system, which we call the fan tail. Now, at that point, I want to say the big new technology was stealth. Everybody in those days was talking about stealth. Could you build an aircraft that couldn't be seen by radar, couldn't be seen by heat-seeking missiles? And we were the helicopter component of that stealth breakthrough. Here we just had a publicity shot where we got the F-117 and the second Comanche aircraft together for a photo shoot. But you can see from that picture, the kind of things we were doing was shaping the fuselage, tucking all of the weapons inside the fuselage, keeping everything very sleek, and designing the thing to have a very low radar signal. One of the other observables, very important in the process, is the infrared signature of the aircraft. Now this gets very interesting because if you walk up to that aircraft, you probably had a hard time figuring out where did the exhaust come out. I'm going to try to. The exhaust, in fact, came out this slot along the tail cone. The exhaust was designed to where, again, I got to chase on the exhaust came out the engines, and instead of being immediately ejected out of the airplane, went into these long ducts down the tail cone. Long fin with these nozzles coming out down the entire length of the tail cone. And then at the top of the tail cone, we had slots where ambient air was introduced and mixed with the hot exhaust air before it was exited from the airplane. So it was a rather complex system, but it was very unique and in fact really solved the problem with infrared heat-seeking missiles. So this is our kind of chart about how do you do it from a low observable standpoint. And the easiest thing is to look at the circles on the right-hand side. We ended up with a command. We ended up with a Comanche with it was all classified numbers, so we weren't allowed to tell them what it really was. But they allowed us to say our radar signature was the size of a bird. It tells us what size bird we can say, but just the size of a bird. But it ended up, it was 1/600th the size of an Apache. On the infrared signature, it was 1/4 the size of the Apache. And acoustics was another thing. They certainly wanted the air to be quiet so the enemy couldn't hear it coming. So on that, we used a 5 millimeter rotor, we used a reduced tick speed flight mode, and we got the signature down to where it was about a half of that of the Apache and the Kiowa rate. And I have to tell you, there's an interesting story that I remember. We had a flight demonstration once down in West Palm Beach, where we had the press, we had Army bigwigs and staffers, we had congressional people all on stands, lined up looking down the runway, watching the aircraft fly. And Russ Stiles, our pilot, comes out and does his normal demonstration, which was pretty dramatic. But then at that point, the narrator standing in front of the stands kind of looks down the runway and he says, now we're going to do a low altitude, high speed pass down the runway. And everybody's looking and there's kind of like a pregnant pause to, what's happening? Something missing. And all of a sudden the aircraft comes across the runway from behind the stands and no one even heard the thing coming until it was right over them. That's how quiet that aircraft was. Now, the other half of our equation about the mission that we were trying to follow was, okay, now you're low observable, so people can't see you. The other thing is you've got to get your mission done and you've got to go out and find targets and prosecute targets. So again, with a lot of the digital technology that was evolving in those days, we had a night vision. We had a night vision system on our aircraft where with the technology of those days, we could see about 40% farther. We had a wider field of view. So we had a distinct improvement over the systems on the Apache. And the same thing with the target acquisition. We had a targeting system that could see about 40% farther out than the current systems. Another interesting aspect down the bottom of the chart was when the Apache tried to survey a battlefield and sort out where is the enemy, the Apache would lift up out of cover and the pilots would be looking at the views on their computer screens or in their helmets. And they had to be exposed about 2 minutes to try to figure out, well, there's a tank and there's an armored personnel character or whatever. And that exposed them for 2 minutes. On our system, you raised up out of exposure. These sensors and the computer gathered up all of the input, took all the data from what I was seeing, went back down under cover, and then the computer displayed to the pilots, there's a tank, there's another tank, there's an armed personnel carrier. So the aircraft was exposed for a very long period of time. So this then got us to probably the primary. I always used to tell people if there's one thing you want to remember about the Comanche, it's the fact that it can see without being seen. No other aircraft could ever do that. The domes in these figures represent the enemy's ability to see you with your radar signature. And the yellow wedges represent your ability to see them. So the Apache on the left is well within the dome, seen long before it ever gets to the target. The Comanche, on the other hand, is looking at the target and nobody even knows he's there. So that again is the key. If there's only one thing to remember with the Comanche, that was its mission. Now at that point, I decided rather than try to talk through all of this, I found a nice video that the Army put out explaining the program. This was done in about 1997. This goes on for about 9 minutes, so I'm going to sit down. You all watch it. You got it?
Yeah, we got it, sir. Thank you. Let me see if my audio is.
During the millennium, threats to American security will be great and pervasive. The world is a safe place. Threat evolving. From drug lords to terrorists to rogue nations with extraordinary capabilities when armed with weapons of mass destruction. Because future threats are undefined, revolutionary asymmetrical approaches to counter potential adversaries. Information dominance provides an asymmetrical advantage, and the developing a new receiver which maximizes this advantage. To fill this role, we're building a Comanche. Comanche, future air cavalry helicopter, and helicopter specifically service the next 6 years of the maneuver commander on the 21st century battlefield. Comanche is a surface aircraft, and the system. System. Target detection system. System. The Comanche can maximize the advantage of the target and implement better information, target identification, commander combat effect, how they target, safe American victory. And that's that of currently deployed helicopters. Comanche will identify and prioritize target fratricide and a battlefield will map target position and make track files for identify target. And this analysis of battlefield situation may be in conflict or in the help of display. The will be easily transmitted throughout a joint and combined arm. The direct flight with the Comanche truly made guys and years of the 21st century. If the Army's effective numbers platform of the future, Comanche will give the warfighter asymmetric power in terms of information, lethality, force protection, and force projection never before known across the range of military operations. With Comanche, we will be able to increase counter effectiveness, our combined armed joint forces exponentially. Indeed, Comanche will give our military the sharp edge needed to avoid combat, except which federal arm for America. Fiscally, Comanche's acquisition cost is targeted much lower than comparable systems. Plus, it will have significantly reduced operating and support position of growth. The approach is computer the keys manufacturing has been a manipulation program. Their designer and really accurate simulator. They to check out virtual validation being manufactured in the aircraft. With them, the whole team, time the design, conduct training, develop doctrinal insight, conduct method to integration, and conduct and procedure. This production aircraft were delivered for a purpose, not the aircraft. The killer I helicopter desert Comanche probably attack helicopter to the jet. Arrow trying to get like that. It will have a take by the fly. And I had fired in 3 seconds. They doors opening. Fire right up. Directing guided surface. The air-to-air stinger. And the Comanche. Let's return right quickly. Comanche. Well, it's matched by survivability. Later, big risk. Red jammers. Pictures. And advanced pressure system against biological the airframe. Let's think their gunfire. Wire electronic control system combined with the added thrust of fantail. Pilot can maneuver the aircraft to the nav. Improvement and maintenance continue built-in diagnostics and prognostics. With the main to maintenance and only 49 maintenance tools able to be transported via ship or cargo aircraft. The Comanche 160 mile range is sufficient to self-deploy and protect from the continent of the United States, Europe, Africa, and the Middle East, Caribbean, and Central America. Protecting effective ability to take information down. Our ability to gain knowledge of an enemy's fighting capacity allow our commanders to anticipate an opponent's actions, surprise him and attack his weakness, and win decisively, ultimately destroying his ability to wage war, at the same time sustaining a minimum number of casualties. The Comanche is a critical element in the future defense of our country and a decisive platform for our gaining spectrum dominance. Comanche.
I'll throw in a little aside here, because I find interesting is, you know, we were all going through this Stevens revolution in those days. And typically, the defense industry kind of led the commercial industry. We were building all these simulators, and we had this digital representation of terrain. And one day, one of the guys who was doing this came into me and was so proud of the fact that he figured out how we could build little green cones and stick them around the terrain to look like trees. And I thought later, you know, it was only 2 or 3 years later, the commercial industry was building games with all kinds of terrain and everything was totally realistic. It was like, I think the first time that, if you will, commercial industry outstripped the defense industry, what they were doing. Of course, they were doing it for commercial benefits. Another thing we did, which is kind of, again, because we're starting a whole new program after a 20-year period of not designing anything new, there's a lot of smart people who decided we try some new management approaches. And one of the first things we did was what we call the integrated product development teams. And in the past, the engineering department would design the part, the aircraft, and throw it over the walls of the manufacturing engineers, and throw it over the walls of the manufacturers who would build it. And then kind of bring it up the rear where all the supportability people, the people trying to figure out how to make it reliable, maintainable, accessible. And that was at the time thought to be the least expensive way of designing a system. Well, with we in the Army got together with this idea, we're going to do it differently. We're going to have integrated teams. We had all those people I just mentioned all stationed together to design the aircraft. So you had the accessibility engineer whose job it was to try to make sure that those electronic boxes could be reached, moved, and serviced, sitting there with the airframe designer trying to sort out how to put everything together. And that was generally thought to be a very successful approach, although more expensive at the beginning to designing the aircraft. We had an expensive systems engineering organization, and systems engineering is one of those kind of glossy terms that people throw around, but means a lot of different things to different people. But in essence, we had so many different requirements that had to be tracked that every designer was given kind of like his input for his design with all the things he had to meet. And then the output as to what was supposed to come out of his design was all integrated and tied together so that we could keep track of the fact that all of the many different requirements of the aircraft were being met as we were going through the design process. We had a combined test team. Again, in the past, the contractor would flight test the aircraft, develop the envelope, make sure everything looked fine, then turn the aircraft over to the Army, and the Army pilots would do the same thing. They'd fly the whole envelope expansion all over again. Here again, the Army worked with us and said, wouldn't it be smarter if we actually integrated the Army test pilots with the Boeing Sikorsky test pilots? So we did that. We ended up coming up with, because it was, here we were teamed with one of our largest competitors. They had their secrets, we had our secrets. We came up with what we called the Joint Program Office, which was a group of about 50 people from both companies, whose job it was to really manage the program, keep it on track, and be the primary interface with the Army. So we, the company, Sikorsky Aircraft, had our part of the job to do. Boeing had their part of the job to do. And the Joint Program Office was there sometimes to kind of get in between us and try to resolve issues when they came up. But that was really necessary to get the two companies to work together. And one thing that people had a real love-hate relationship with was kind of what we call the earned value measurement system. We had a very complex plan for this aircraft where every, if you will, man month, 160 man hours worth of work was identified in advance and estimated before we ever signed the proposal. And again, the definition of what was to be required to start that work package, what was required to close the work package. And it drove everybody nuts because it was an intense amount of work. But on the other hand, management knew if you were off track for just a half an inch, you couldn't bury the fact that you're over budget or you're behind schedule. That was really an amazingly positive method for management to keep track of the program and make sure we never got off track costing it. So we never get. Now, what I'm going to do Okay, now a little bit more about the design itself. I mentioned we had a bearingless rotor. The rotor used a flexible element, if I can find it down here, to replace all of the hinges. And that flexible element was then covered by a cuff, which was attached to the push rod and the swash plate for control. So this eliminated all the hinges. It was built out of composite materials, again, rather than metallic materials. It led to a stiffer rotor, a more rigid rotor, which gave the aircraft much more maneuverability. And again, there were a lot of people at times saying, we can't do that, we need all those hinges. A lot of people said, no, we can do that. We saw how to do it, and we did it. The movie talked about fly-by-wire. This odd-looking aircraft, again, was kind of one of the fun things we did on the program. This was an S-76, and we took a single pilot cockpit and globbed it on the front of the aircraft to try to test out the whole idea about fly-by-wire and some of the advanced concepts we had for the cockpit. And I have to say, because I have a personal experience with this, when they did that, what you're doing is replacing a large displacement cyclic stick in front of the pilot with a small displacement joystick, like you might see on wheelchairs or things like that. Well, a lot of pilots couldn't do that. They had a hard time figuring out, what am I doing here? I'm used to this. And there was actually concern at the time of, really, are we going to be able to make this thing work? Well, again, some smart people turned around and said, what we got to do is we got to find some people who aren't pilots, see if they can fly. So they picked 4 or 5 people out of the engineering department, including me, and said, we're going to see if you can fly this airplane. So they, and not being a pilot at all, they put me in the front seat, and they didn't let me take off from the cover, but they got the thing up in the like a hovering flight at 50-foot altitude. I was able to fly the aircraft around, flight fuel, do some maneuvers, yaw the thing around, bring the thing back down, and it worked fine. And so were the other guys. So they kind of left with the idea, okay, this can work. We just may need pilots who aren't used to the old way of doing things, or we may make sure we get pilots who can be retrained. I mentioned the composite fuselage. Composite materials were just coming in. These are graphite composites, so we're just coming in. But we decided we could build the whole thing out of graphite composite rather than sheet metal. One of the smart Boeing engineers also came up with an idea that said, because we have this odd-shaped airplane where we're having missiles and rockets coming out, the landing is coming out, we've got access panels for getting at all of the electronics, the whole side of the aircraft is going to be covered with holes. Very inefficient from a structural standpoint. So his suggestion was, we're going to build what we call a center box beam. Here's my use of this thing. So what we had is this.
You want me to point?
I think I'll skip the point. What we had was a very simple structure inside the outside skin of the airplane. It was square, it was boxy. The side panels of that graphite material were 26 feet long, one piece 26 foot long, with a couple sides, the bottom, you had some bulkheads that you put in. It was a much simpler structure. It ended up with like 350 pieces of graphite to build a fuselage, whereas the Blackhawk is 6,000 pieces of sheet metal. The other thing that we found was to put it all together, because everything was designed and machined on these new digital machines, is we try to explain to the manufacturing people that this thing is going to go together like a simple puzzle. Of course, they're manufacturing people, and yeah, you believe that when you see it. So it ended up, they scheduled 2 weeks to put this basic structure together, and it ended up, they did it in less than 1 day with 35 man-hours worth of work, because everything just was all digitally designed and all put together. No, it's totally good. We did, as I say, use an electronic mock-up. That's kind of a crummy illustration, but that's the best I could. Everything was designed electronically. The gearbox, you mentioned before, all big helicopters up to those days had a planetary gear set, which was very complicated, but which is really necessary because the torque coming out of the last stage of the main gearbox of a rotor system, which is coming out at very low speed, coming out at rotor speeds, is too much to be handled with one set of gears. You got to split the load among the many gears. And the planetary did that with like a 5 planetary gear set. And the other disadvantage with the planetary is you could only get a reduction ratio of about 2.5 to 1. We came up with this idea that we called split torque.
I'll get you back. I got
Okay, now we're going to try to use the pointer while I'm missing. In essence, the output from each engine was split in two, with spurs going up to the final drive ratio. So you had four inputs into the final drive to share that torque, and you could get a very high reduction. So this was very successful. It's gone on, I understand, in the 53K and a number of other Sikorsky helicopters. I don't think anybody uses planetaries anymore. That was new with us. Supportability, this idea of large access panels, I've kind of covered already. But what I really want to say, what was interesting is when it came down to the final down select between our design and the McDonnell Douglas Bell design, technically, it was kind of a wash. We were good here, they were good there. The thing that was interesting was they really gave us kudos for the way we designed the aircraft where it could be maintainable. And you could get it all the necessary parts, perform it quickly, we reduced the amount of maintenance, and that in fact was the thing that the supportability people at least would tell you one problem. They're not wrong. Here's a little shot of some of our toys. There's the shadow on the right that I showed you before. The middle is the mock-up of the Comanche. We hadn't built it yet. On the left-hand side is another S-76 that we modified with a fantail. We had previously flown a fantail on a bigger airplane, the S-67, but we wanted to put it on an aircraft the size of the Comanche to demonstrate that we really could do everything we were supposed to do as far as yaw control. This is interesting. The aircraft, the Army named the aircraft the Comanche. The Comanche Native American tribe down in Oklahoma really jumped right in. They loved it. They helped us out with all of our publicity. They went to all our events. They shook hands with the senators. And they were helping us market the Comanche helicopter. Fun thing, Tom Clancy. Tom Clancy was an author who wrote military mysteries, very famously, widely respected and widely popular. He at one point called us up and said, "Hey, I'd like to write a book about the Comanche." So we invited him in, spent the morning, you can picture this, he's in a conference room, standing room only, everybody wants to see Tom Clancy. And we, take the morning and explain everything to him. And then as the day went on, the crowd diminishes and it finds up with Tom Clancy and his assistant and Russ Stiles, our pilot, in the simulator lab. And Russ kind of tells a story about, he leaned in and he said, "Now, this is what I want to do. You think we could do this?" Of course, Russ said, "All right, let's go on the simulator and try it." And they did it, and he wrote the book. Garth Brooks might not be somebody you might associate with the Comanche program, but he in fact was with us when we rolled out the aircraft in the Capitol, outside the Capitol in Washington, D.C. on the National Mall. Kind of a strange story. The USO sponsored the event. They combined it with a celebration of John Wayne, the Duke. They named the aircraft the Duke. And lo and behold, Garth Brooks is a big John Wayne fan, so he wanted to be part of it. So he was there again, introducing our aircraft to the senators. Now I go to video number 2, which is the aircraft flying. This chart I actually stole from our project pilot, Russ Stiles. I liked it because I like the way he titled it. This is Flying the Comanche, the Thunderbird. So here we come with a video. This is actually from a television station down in Miami Beach. So I just want to thank you, by the way, for getting these videos. Yeah. Good. Appreciate you pulling them. Yeah. You know, here we are. We've got this tremendous product. We're all looking forward to a great future. We're going to keep the company going after the days of the Blackhawk, and somehow it didn't work out that way. So what I'm going to walk you through now is what we could call the invertible shrinking program. The Army, first off, sorted out they could not do a competitive fly-off. They couldn't afford to fund both aircraft through that design phase. So they did a paper, a down select, if you will, and we won. The utility aircraft was eliminated early in the program, which was about half the aircraft. They decided that rather than go to a production design, we better build some prototypes first. They eliminated the competitive fly-off. They eliminated this idea of the two winning companies competing against each other because there weren't enough aircraft anymore. By the time we got into our contract, the 4,929 aircraft was now down to 1,296. They were going to have us build 4 prototypes, and the initial operational date was going to be December of 1998 with a $5.3 billion program cost. And that went on for a good solid 2 years. Then we got a restructure in January of 1993. Major funding reductions from the Army extended the program out to 11 years, 6 months instead of 7 years, 7 months. 4 prototypes were now down to 3. And the Army, at every opportunity they could, they decided, let's call on some more equipment because, hey, we got some more new fun stuff that's coming along. Let's put that on the aircraft. The IOC was now in 2003 rather than 1998. And the program cost went up a little bit. That was 1993. Then we get to December of 1994. They had us identify what they call the streamline program. The funding were reduced further. They added 3 more months to the program slip. We're down to 2 prototypes rather than 3, and more stuff was being added. 1994. May of 1995, they came with the early operational capability program. Funding reduced by $2 billion in the early years, but they kind of stuffed it in the later years, which didn't help us much out with our schedule. The one positive thing that they did is, one part of the program when they decided they were going to build prototypes, they kind of ignored the idea about are we ever going to get into production. So this developed program, in fact, identified that there was a path to production. So that was a positive for all of us. And they added 6 production aircraft. The program was extended for 4 more years. The IOC is now 2006, which I think is the date that that person on the TV mentioned. And the program cost went up by a little bit more. The 5th restructure of Milestone 2, which is the move from the development program to the production program, was moved to the left 2 years, and that was good for all of us because we wanted to get the thing in production. They added 8 more initial operation aircraft, added some more development, accelerated the development of the MEP, and the program cost went up a little bit more. Then by 2000, we actually got to the contract phase where we had finished our original contract, which was for the demonstration and validation. And a major milestone for all of us, we moved into the E&D program, engineering and manufacturing development. 5 new EMD aircraft, 8 AOC aircraft, more additional requirements. The aircraft was getting heavier and heavier with the Army throwing more equipment on, and we going through a lot of development things, which added to the weight of the aircraft. So we increased the diameter of the wing. Now the production quantity was reduced not by much, but 1292 to 1213, and full rate production was identified for 2010. And for those of you who might have seen it somewhere in the past, the whole South Avenue, not the whole, but a large major part of the South Avenue plant, the old Bridgeport Sikorsky plant, was turned over to the manufacturer of Comanche. And we were full up and going with building 5 new composite fuselages in that plant. And again, everything was very positive. But then by 2002, we came up with another restructure. This time, because we were kind of chasing our tail as far as schedule and budget is concerned, it was decided to do the aircraft in blocks. First a training one, followed by an armed reconnaissance one, followed by an attack one. The RC was again delayed from 206 to 209. And look at this, the production quantity was now down to 650. So we're really chasing our tail here. The total production cost was reduced substantially because of that reduction in quantity, and again because of the fact that the early movement, so we were trying to get the budget straight before they even turn the phone. Well, here's a very positive. On December 5th of 2003, the Vice Chief of Staff of the U.S. Army, Richard Cody, flew the aircraft. And you see what he said, take the aircraft to STOL review. Cody said that Comanche had exceeded his expectations and was particularly impressed by the rotor system and engine response and control. He said the aircraft was easy to fly. It should be put in the hands of the soldiers as soon as possible. So what could be better than that? That was December of 2003. February of 2004, the program was canceled. And the program was canceled for the obvious reasons. They were running out of money. And we were kind of increasing the estimate to complete, as you will. This is a rather complex chart, but I like it because this is the actual chart that the Army used to President Bush when he was explaining to President Bush why they needed to cancel the Comanche program. And they turned around and they said in the years coming up that they were dealing with, they had $14.6 million in money in the Comanche program. That could either buy them 175 Comanches, or it could buy them everything on the left-hand side, including 796 new airplanes. So they kind of went to the president. They themselves decided this is kind of an obvious decision. So the president agreed, and on that following Monday morning, they canceled the program. But the other thing that I leave with a slightly positive note is here again, we had our friend General Cody. And he says, at this public press conference where we're canceling the program, he says, I think the only general officer that's flown the Comanche, and I tell you up front and pass on to my friends at Boeing and Sikorsky that are on this team, that they built a tremendous aircraft. It's the most flexible, most agile aircraft that we ever produced in this country, and the people that built it ought to be very, very proud of it. Tremendous flying characteristics and leap of technology that's going to help us as we move forward. So that was that. We didn't build the aircraft that would help the company in the next 20 years after the production of the Black Hawk terminated. But for all of us, the Black Hawk's still going strong. We've now built 5,000 of them, and I guess we didn't need the Comanche to keep the factory going. But it was a sad tale for all of us. It was like 15 years where this was to be the future of the company. Now with that, I will stop and ask questions. By the way, George Chappelle has provided us with a couple of models of the aircraft which are up on the front table, which you might come out and look at if you want. One of them is a very simple design, with nothing but the weapons bay open. The other one, which is more complex, is a little wheel on top of the rotor system, has all of the weapons deployed with an auxiliary wing, kind of like the more complex design, but you might find it interesting to look at those. Yes.
What happened to the few prototypes?
They are down at Fort Rucker, Alabama. The Army has an aviation museum down there, and I don't think any of us have been down there to see it, but we're told they're on display down at Fort Rucker. They don't? Yeah. You know, we've talked about that. The interesting thing was when they wrote the requirements to replace all of those small light helicopters, and then Comanche went through all that effort and then it was canceled. The requirement didn't go away. The Army still has the same requirement to replace the light helicopters, and that's still reflected in the designs they're doing right now. They had a couple of false starts. They were going to try to build something in the interim to replace what Comanche was to do, but they really have gotten nowhere in the last 40 years. They're right back to where they're still trying to come up with an aircraft that has those same capabilities.
Well, I was on the committee that the Army Doctrine Committee established the virgin FDL requirements. And these are four-star generals that were on the committee. And I can tell you that the conclusion we reached was that the aircraft that was needed for the U.S. Army was a Kiowa Warrior replacement and not a Black. So you can imagine I'm kind of a little befuddled that the Army's kind of changed the order of all this. But then again, perhaps some of the explanation you got is an example of the kind of situation. Because Army just doesn't yet seem to have the staying power that Navy and so some of the frustration that Art was talking about, I think ought to come out. It was a little frustrating. We built a great aircraft, probably the greatest helicopter our companies ever produced, until perhaps now. I think those of us who were part of that team believe that a great mistake was made in the nation's bank. We had 500 Comanches in Ukraine, which we damn well should have. You can imagine the situation. It's ridiculous. And we had it, and we did it, and we don't have it. So many of us feel it's tragic.
So is there something we could have done to protect, to not, it seemed like there was a bit of smoke, but were we powerless to do anything? It seemed like a sled ride down to a failure, but was there something we could have done?
In hindsight, and we talked about this a lot, is it would have been smart somewhere in maybe the late 1990s, try to get an A model in production with what we had. Like we showed, it was flying great. We did not have all of the electronics developed, but there was enough electronics to perform a reasonable mission. We probably should have proposed, let's drop back and build a simple aircraft and get it in production sooner. But I was really involved with that one. I would think that. We thought, in fact, we thought this aircraft was so tremendous, no one could ever turn it down. And that works until you get to the point that they run out of money.
Did somebody retire? That chart you showed is pretty. They came up with that out of.
Well, there's always politics in all of this. We I think believe that as the Army's chief of staff changed from one general to another general, we got generals who had different priorities, and that might have hurt us a little bit in the end too. But,
well, there were also people who were labeling the aircraft as as a relic of the Cold War. In reality, there were people who believed that we would never have to fight the Russians ever again, or ever a serious adversary other than perhaps the Middle East interludes that we've gone through over the last 20 years. And as such, they didn't need an aircraft with this kind of capability. Many of us disagreed. We went through huge studies, frankly, to decide that we needed those kinds of abilities. We needed the acoustics, we needed the IR, we needed the RF. Why? Because we knew what the Russian seeker heads looked like. We knew every one of them. And we did all the studies and the trade studies. The Army didn't give us these requirements. We evolved those requirements, and then we got them validated. So you might ask me, aren't those requirements still there? And I'd say they damn well are.
No, the answer is the question. The requirements haven't changed.
requirements haven't changed.
It's still the same. In fact, if you go, one of the patches that's on the table is from 1979. program started in 1979. You told us on the program. And the requirements are virtually what you're working with FARA today.
And if you look at FARA, you'll see the exhaust looks pretty similar. Certain things look pretty similar.
It's not by accident.
No, I know.
Luckily, some of the technology has moved forward. You know, if you look at the F-35 right now, it has the helmet mounted system we developed for Comanche. That's where all that technology went. So your frontline fighter has our helmet flying in that cockpit.
Are there some other examples of the technology that this has propelled? A composite airframe, obviously.
Well, fly-by-wire, pretty common, really initiating all that, proving that works. Composites, of course. I think Murray was just telling us everybody builds split part gearboxes now. We don't do planetaries. So, yeah. Some of the technology.
The stealth technology, we can't talk about it. Stealth technology hasn't been replicated anywhere yet. Okay, on a helicopter. You'd have to read all the documents to know what that aircraft really had inside it. Just, it's phenomenal. Amazing.
Okay, thank you very much. Yeah.
So a few slides ago, you talked about systems engineering, integrated product teams, and did that make a positive difference?
I think it made all the difference.
I think the team spirit was fantastic. Many of you don't know, I was VP of engineering all those years. And I would go over there. I didn't dictate. In other words, they were an independent team. And it was kind of hard. I become an advisor. But it worked. It worked really well. And I supported the concept of the independence program. So they had a very streamlined decision process. And a great, take 56,000 people to make decisions. A few people on the teams. But the same kind of problems that you guys are facing, the same weight problems, the same endless discussions, those are exactly the same problems that this team faced. And I'm happy to say they faced it very well. So, some of us retired thinking that this thing was done. We did our thing. We're on the production line, then we get the call. It's not good. So you can imagine the shock that many of us were actually shocked.
And I will also say, what I was finding interesting is in the Black Hawk days, UTAS days, because we were a competitive program, the goal was to get this aircraft up in the air, flying as best as it possibly could, so you could beat the other guy and win the contract, which we did. But the problem was the aircraft got into the air, what you might say, somewhat immaturely. There were a lot of things that still had to be developed. We didn't have that problem with Comanche. We weren't in a competition with somebody else to get there sooner. We had the integrated product teams that were doing all the ME and the manufacturing and the supporting work along with the designers. So when we got the aircraft in the flight test, it had some problems, but it had remarkably few problems in flight tests. And personally, as I was in charge of the program, one of the frustrations I really had when we were planning the future is there were people that were looking at the Apache program and the Black Hawk program and all of the costs that were involved in those programs after the initial first flight and first development. And they wanted to tack all those costs onto the Comanche program because they knew we were going to have the same problem. We were trying to tell them, no, we're not going to have those same problems because we designed the thing very slowly, collecting data as best we could. And that was one of the things that threw some of the cost estimates off in the final years. People were adding a lot of extra costs, which we didn't think were necessary.
A lot of people forgot that after we won Black Hawk, that wasn't the aircraft, that's the Black Hawk.
Yeah.
We changed the Black Hawk completely between 1974 and 1976 and 1979. We put 4,000 changes. And some of them quite serious. So that's what he's talking about, because the cost estimators thought that was going to be the case. We didn't.
Hopefully.
Yeah, so, I mean, I worked Comanche not as long as George, but.
Nobody.
Nobody.
Nobody was crazy enough to do that.
10, 15 years is kind of a while. And I don't remember seeing that quote at the end. It was canceled. There was something that happened at Sikorsky where it just hurt so much that people didn't talk about it. And that's understandable, but it's really cool to be here this many years later and like hear the pride, not haughty, but the pride in some of the stuff we've done. Some programs will come and go, and we'll probably lose. I mean, I lost a lot of competitions on proposals that I worked. It's good to have a healthy perspective on some of the great things that we've done. Not perfect, but I'm glad that, this is an important part of Sikorsky's history. And I'm glad that even I'm working with Laura now, it seems okay to talk about Comanche, which is funny because for a while there it seemed like, yeah, thank you, George. Yeah, it did. Because some of the younger folks just realize that. Like,
I'll go out of school. There were certain people in management around the 2004 time wanted to erase the history of this aircraft from the company. You will find that they took all the pictures down. I retired in 2004. For a couple of those reasons, had to leave the company. All the Comanche stuff was moving. You went up the escalator and saw the pictures. The Comanche picture was taken down. You walked, yes, it was. You walked in the aisle up to the workman's aisle. Comanche picture was taken.
Mr. Nesbitt is straight up.
The models were taken.
There was that cultural.
So in that, in my last years, I was working at the design. You couldn't talk. I talked about Comanche in the beginning, but you couldn't talk about Comanche at all. It was kind of like verbal. It was very sad for me. I worked on a program almost 23 years. Big part of my career. And by the way, Arthur wrote the book, so make sure you get one of these because Arthur documented the history because some of us were so concerned with the history of this aircraft. We wouldn't take it to the Smithsonian. I'm glad the X2 made it. We would not take Comanche. There's so much technology there that we can't even talk about.
One of the reasons that I believe was the Army aviation budget. It's historically been very small. This nation has always been very, very much a naval and air power. Really has never funded the Army adequately. We were fighting a war in 2004. Well, so Army aviation leadership was suffering from where was the money coming? They couldn't keep the existing Blackhawks and Apaches or even field newer ones in the air at the same time as fielding this young Comanche program. They couldn't afford it. And one of the dangers that we face on FARA and FLORA is programs stretch out, and yes, the Army aviation budget. So I certainly counsel you guys to be aware of that.
One other, don't let them keep changing requirements. That was one of the main.
It's out on the BH.
The second, how many meetings that a lot of us got into trouble arguing with the Army because every time the leadership changed, a new general and a new TRADOC guy came in and said, and I remember specifically, like, I'll give you an example. We had spent 5 years working out all the symbology on helicopters. 5 years. It was really, really rough. The TRADOC guy came up and said, I flew it, I'd like to change it. So that's just one little example where the new guy on the block comes in and says, well, I'm the new guy. So I need to look at all the requirements again and say, well, that's why I brought this model on the right-hand side. That aircraft never got built. Exactly.
And we flew some of the parts, but you'll see that the aircraft was supposed to be an armed reconnaissance aircraft. Go out there and find things.
A light.
Light.
Why does it have to carry 16 gunfires?
In the end, the weight requirements kept creeping, but if you look at it, it's got EPAMs on it. They added a couple of wings on us, put another set of Hellfire launchers, another 8 missiles on the airplane. What did that turn into?
Mini Apache.
That's right, because the last guy that came out said, this is going to be the Apache replacement. And that started to kill the program. Because now, let's talk out of turn, Arthur.
Who's our partner?
Who's our partner? Boeing.
But what do they do?
What do they do? Apache.
But remember, they were not our original Boeing partner. The Boeing that we partnered with did not own the Apache.
Not at that point.
McDonnell owned the Apache.
They did in the end.
McDonnell got bought by Boeing. So we found ourselves having a partner that was our.
So you can see it as the aircraft now is maturing very nicely, actually. And the TRADOC guy is turning it into an Apache. You've got Boeing management going, now wait a minute, where's that going? So I just throw that in. I know Arthur probably didn't want me to say it, but five guys decided to kill the program. But there are other things that were involved in that equation.
So that's our walk down memory lane.
Thank you.